Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to do Lesson 10.7, Areas of Circles and Sectors. Definition, a sector of a circle is a region bounded by an arc of the circle and two radii of the arc's endpoints. All right, so the area of a sector will just be a fractional part of the circle, and we can get that fractional part by using the idea that we know there's 360 degrees total arc around the circle, and so whatever portion of that arc is, that'll help us get the portion of the area. Okay, in your notebook you'll notice that this is not filled in, and I just filled it in so you could see. Go ahead and look at the numbers and see if you can figure out what's going on here. You'll have to, of course, read that. Be a good time to pause. What you should notice is that as the number of sides gets bigger and bigger, the perimeter seems to be getting closer and closer to the number 2 pi, and the area is getting closer and closer to the number pi. All right. So just a quick review, the area of a circle is pi r squared. Generally, we're going to leave our areas in terms of pi here. So if this radius was, say, 5, then we would give the area as 25 pi. All right, so what is the area of the circular skating rink with a diameter of 48? And of course, this is review for you, so I think this would be a good time to pause, get your answer, and then just see if you got your answer right. Remember to leave your answer in terms of pi. Well, if you did that one correctly, you got, of course, the area is equal to pi r squared. And our radius in this case is 24, so we're going to do 24 squared times pi. And that's 576 pi. All right, now to find the area of a sector of a circle, once again, you're going to take the fraction of 360 degrees that you have for that sector. All right, so that's what this is saying right here. Find the number of degrees in the measure of the arc divided by 360 and then times the area of a circle formula. So in this first one, and we're going to leave our answer in terms of pi again here. We're going to take 84 out of 360, and we're going to multiply that by pi r squared. And our r in this case is 9. 84 over 360 simplifies to 7/30ths, and 9 squared is 81, and then do that times pi. 7/30ths times 81 equals 189 over 10 when written as a common fraction. I like that, of course, and times pi. All right. Go ahead, you try it with this one. See if you get it right. If you did all that right, you got 2 pi. All right. The other thing we're going to talk about is the segment of a circle. The segment of a circle is a part of the circle bounded by an arc and the segment joining the endpoints. To find the area of a segment, what we're going to do is imagine that center of the circle. And it looks to me that if we wanted to find just the segment part, we would find the area of the sector. and then we would subtract the area of the triangle. All right, and that's what this concept is telling you. So you just have to find two areas, the area of the sector and then the area of the triangle. Let's go ahead and try that. The area of the sector, in this case, it's 90, so we're going to do 90 divided by 360, which is 1/4, of course. So let's just do that, 1/4 times 7 squared, which is 49 pi, that is the sector. And then we're going to subtract the area of the triangle. Let's put this little triangle over here so we can see a little bit more. Remember, it's a 90-degree angle, and these two legs are 7. So that's your base and height. So it's 1/2 times 7 times 7, which is 49 halves if we write that. So we end up with 49, 1/4 times 49 is 49/4 pi minus 49/2. If we were to leave that in terms of pi, we would, you could change those fractions to decimals or just leave it the way it is right there. That would be fine. You could also write them as decimals, and then you would have 12.25 pi minus 24.5. And then since it says round to the nearest whole number, we're gonna go ahead and calculate that. And it looks like we get really close to the number 14 for the area. All right, why don't you go ahead and give that a shot? All right, here's my work. I hope that matches up with your work. I think we should do one more problem here, and that's number 3, because finding the area of this triangle is a little bit different. So on number 3, we're going to first find the area of the sector, which is all of this, and it's 120 out of 360 degrees, which is 1/3 times pi r squared, which would be 2 times 2 times pi, or 4 pi, and we're just going to write that as 4/3 pi. Okay, and then the triangle, I'll just draw it over here, enlarge it a bit. We have a 2 and a 2, and we know this is 120 degrees right here. We just recently used a formula, and you probably wouldn't have thought to do this, that works really good for this. It's the area of a triangle is 1/2 AB times the sine of C. So we're going to do 1/2 times 2 times 2 times the sine of C. When I do that for the area, I get about 1.73, goes on, and I'm going to simplify that by just rounding it to the nearest hundredth, say. I'm going to keep that whole number in my calculator while I do that, though, so I can keep it as accurate as possible. And when I do that, I get about 1.73. Oh, that was my last answer, sorry. About 2.45. Say 4/6 rounded. Now, since it says leave your answer in terms of pi, that means there must be another way to look at this area of this triangle without needing to use trigonometry. And actually there is. And so let's do it that way also. So here's the triangle again. And I'm going to just draw that line there, the altitude. We know that this side is 2. We know this side is 2. And since I just split a 120-degree angle in half, we know that that's 60 degrees. And so this is a 30, 60, 90 over here. So this short side would be 1. And then this longer side over here would be 1 times the square root of 3, which is the square root of 3. So the area of that triangle is 1 times the square root of 3 times 1/2. Base times height times a half. And so that equals the square root of 3 over 2. So that's the area. So now writing it in terms of pi, we would have, remember we had 4/3 pi for the area of the sector, minus the square root of 3 over 2 for the area of the triangle. All right, so in that case, we left it in terms of pi. All right, good luck with this assignment. We'll talk to you soon.